environmentals. There really hasn't been a whole lot of documentation on crop producing plants yet, but I feel like that's coming too. And then your second question, can you repeat that?
So like when you're measuring the VOCs, how do you determine if they're benign or non-benign?
Sure. So measuring VOCs gets really complicated really fast, and that's something we've learned throughout this project. There's a lot of these commercial grade VOC sensors for HVAC applications that for the research that we were trying to do, we actually found out they were pretty worthless. They're based off of, the sensing technology is metal oxide, and so what they do is they create this like boundary layer of oxygen, and anything that reacts with that oxygen will then create an electric potential and then an electric signal, and that's how you're sensing it. Unfortunately, it's anything that reacts with oxygen, it's going to read as a VOC, but it doesn't tell you what VOC you're measuring. So the next step after that, and that's kind of that's the cheap method. The more expensive method is something called gas chromatography mass spectrometry. I can never say that right, but basically it's taking an air sample and pushing it through a vial and seeing how quickly it comes out at the other end. And based on how quickly it comes out at the other end, based on like a number of reactants that are in that vial and things that can slow it down and things along those lines, you can tell based on the time it takes to get from point A to point B what VOC you're looking at based on like pre-calibrated data and stuff like that. So there are methods, to really get at what you're asking, there are methods to determine what VOC is what, as long as we have a pre-calibrated amount of that VOC when you start. And there hasn't been as much research done on the benign ones, but they're recognized as something that is worth considering when you're looking at plants and VOC reduction. Sure.
Great presentation. Congratulations. Just a question so I can understand how it works. Is the BioWall a standalone system, or does it become part of the HVAC system?
Sure. Yeah, I always forget to really talk about how this fits, but it's the return air of an HVAC system. So you've got your supply air, which is the amount that's being brought into the space. So like you see the diffusers on the ceiling, that's bringing in our supply air. And then there's return air, which is in grills, which is taking the amount that came into the space and then bringing it back out into the air handling system. Well, it's in that return air that's where we're placing the BioWall. So in an energy efficient residence, we would have about half of the grills, the ducting would go into the BioWall, and then, well, not the grills, so we'd have individual grills, and then we'd have the BioWall, and half of the return air would be passed directly over the BioWall, and then it would be mixed, and then it'd go back to the air handling system. So that's kind of where it sits, is within that return air ducting.
Talk about adding protein into the system. Have you thought about using fish? It adds a lot of complication to it, but it's like a aquatic system. It's simply what they.
No, and that's a cool idea, and it's something that it's something kind of in the back. We don't have a lot of expertise in that area yet, but as kind of a longer term goal, it could absolutely be part of the
fish
project.
next to it, it's more of a healing of a hospitality.
Yeah, I mean, you could have an aquarium right next to a BioWall, and that'd be kind of interesting. Another thing, which is a little less pleasant, but I have a friend who does a lot of work in wastewater, and he is working on a system that he calls P-Ponics, which is basically using gray water from bathrooms and stuff to water the BioWall. And this, actually, they did this in some of the Russian deep space experiments. They used this idea to provide, I think, a lot of nitrogen to the plants. So there's a couple different things that you could incorporate with the BioWall. And actually, the guy from NASA has a house that has all sorts of these plants, and he's got his own hydroponic system. And I think he's got aquariums, and I think he might be using some of that P-Ponic idea as well to make it more of a holistic system instead of just one individual BioWall.
You need to return the water back into the tank.
Yep, and you could have the fish clean the water, and then you can harvest the fish. Yeah, absolutely. Other questions? Sure.
So you said that it has lights on it. Is there any way to have it be
Yes.
Would that be enough light?
Yes, so the reason ours has lights on it right now is because we put in that environmental chamber and there's no windows on that, because it's, you know, it's meant to be a controlled environment. But ultimately, we're thinking that a lot of these inputs, such as the lighting, the drainage, the water requirements for the plants, we're hoping a lot of those inputs could be designed into the house. And that's kind of why our scope is, you know, new construction for energy efficient residences, because we could see, you know, natural lighting, you could orient it so that, you know, the plants get all natural lighting with enough windows. You could do a stormwater runoff system to provide the water to the plants. There's also that gray water idea I was talking about before. So although we have these different energy inputs right now, we're hoping longer term that those wouldn't be as necessary. Yeah.
The introduction of activated carbon into the system seemed to have a significant effect. Am I correct in that?
No, absolutely.
Is it, just from an order of magnitude perspective, is that one addition more than the benefit that the biowall was providing?
Yes, so the thing that's happening there is, so activated carbon, it's very porous, and as you take these VOCs, these chemical compounds, and pass it over activated carbon, it adheres or adsorbs to the activated carbon. And so what we're seeing there in what the future of the biowall project we think is, since, you know, with activated carbon, you've got all these VOCs and they stick to the surface, and they keep, you know, it catches them in real time. It's very good at filtering them, but it saturates, because as you get more and more that stick to that surface, eventually it runs out of surface area, and the activated carbon gets saturated, it doesn't do its job anymore. Well, what we're thinking is that in real time, that activated carbon can catch things, and then more slowly, we see the plant roots come in and bring in those little microorganisms to clean up the activated carbon.
So my second question was, can that be the growing medium so you have more contact time with the roots to allow the natural process, which probably is, you know, just air over a plant root is probably too fast, right?
Yep,
So,
exactly.
All right, that really makes
And it
sense.
wouldn't be very good for the plants either.
Yeah, so maybe it's too early, but eventually you use the activated carbon as a growing medium and assume that you won't saturate the activated carbon. Is that where
That
you guys are
is
headed?
exactly where we're heading. So, and there are, so like if you went on Granger, which is just an industrial supplier, and you looked at different products on there for like air filters and HVAC systems, you can find a activated carbon air filter. And it's made out of very similar growing material, not growing materials, it's made out of very similar materials as some of the other HVAC filters which we have used and we have shown that we can grow plants in. So we're thinking that if this is the same thing with just a little bit of activated carbon in it, then we would definitely be able to grow plants in that environment and then have this, you know, combination system between the activated carbon that captures things in real time and the plant roots which slowly, you know, unsaturate the carbon. Questions? All right, well, I guess that's about it. Thank you, everyone.
What about video?
Oh, yeah, okay, yeah.
Yeah, you should definitely play it. I definitely want to see this video.
Yeah, I don't think Michelle wants to.
Naomi Michelle is starring in said video.
Your manager is theater.
We'll see if the internet.
No, I was recycling.
It's on the interwebs. It's on the website if you want, if that's easier.
Yeah, also check out our website. We've got www.purdue.edu/biowall. And that'll take you right to our project if you're interested. This is our team. Let's see. Where on the website is it?
guys start this project?
So the project started in 2011 with the work that Kevin Rogers did. My portion of the project started in fall 2012. So I'm working on my master's degree right now. I should talk a little bit about that. So I'm a master's student in ecological sciences and engineering, as well as mechanical engineering technology. And so hopefully graduating in May. So this is kind of bringing everything together and presenting the research is where I'm at.
If you guys got the phase 2 research grant, when would that be?
So that's, how we were talking, or I was talking about the next 2 years of the project and how we're going to reevaluate it and redesign it and then implement it in Whirlpool House. That's the time frame for that second phase project. So we're already kind of making plans like you did. And then even if we don't, we still have some funding from ASHRAE, so it's not like the project's going to stop dead in its tracks if we don't get the CPA grant.
Well, there's also several, either live wall or some other manufacturers out there that could easily probably say, hey, well, sure, because you are finding